presentation. Okay. Yep.
Well, hello everyone. My name is Josh Polk. I'm site director in Indianapolis. And before we get started with our special guest today, I just want to mention that some of our programs that we offer at Purdue in Indianapolis, we have an undergraduate program in themed entertainment design, and we also offer a minor if you're a student in any, themed entertainment is multidisciplinary and we love to get students in for a minor. We also have a non-credit certificate program, and pretty much all that can be found at Purdue, www.purduethemedentertainment.com. So, however you're coming in here, we appreciate you and would love to hear from you sometime. All right, so we have special guests today from Schmidt Associates, Joe Jarzen, and I haven't got the names of the other guys yet. I'll let you all introduce yourself, and we'll kick things off. Thanks for coming.
Excellent. Thank you. Thanks for inviting us. My name is Eric Bramel. I'm a principal in charge of engineering at Schmidt Associates. I'm a mechanical engineering grad from Purdue from 91, and I'll let my colleague introduce himself as well.
And I'm Bill Gruen. I am the Energy Services Manager here at Schmidt Associates, and I have a Energy and Environmental Studies master's degree from Boston University.
All right. Uh, what we wanted to do today was just kind of give you an overview of how what our industry is like, and maybe share a few experiences along the way that have formed how and what we do now. So we'll start by just kind of briefly introducing the AEC industry, which is the architecture, engineering, and construction industry. Touch on a few of those disciplines from mechanical, electrical, plumbing, and technology. Also, energy and electrification is kind of where Bill will pick up and go forward. So the AEC industry, like I mentioned, it really is kind of the three letters reference the architectural component, the engineering, and then the construction components. And I guess my main comment here is one of the things that benefited me the most in my career is being on the construction side early in my career. That really made me a better designer and a more practical designer. So I spent 15 years in the controls industry, which is so HVAC controls, building automation, that kind of thing. And from that, I gathered a new appreciation for simplicity. I would say it would be the overall theme, and just I think also being involved in the construction of buildings really gave me a lot of nuts and bolts practical experience on what works, what doesn't, what's complicated, what's expensive, and what's simpler to operate and what's more cost effective to operate. So with that as a backdrop, we'll start off with the MEP engineer's role in the process. So, like we mentioned, architecture and engineering work hand in hand. Schmidt's a full service firm, so we have all that in house, and we try to leverage that as much as possible so that architects and engineers are on the same page from the beginning. That's not how the whole industry is. There's quite a bit of separation of different firms. So a lot of times there'll be an architecture and interiors firm and an engineering firm, an MEP engineering firm, maybe a civil engineering firm. There may be three actual different corporate entities working on a single project. And to the degree that we can bring all that in house, short of structural, we'll do that. And the majority of our work is done with all in-house employees, although a lot of times we'll get into teaming situations where we're working with an outside architect, or any number of combinations of different disciplines in different organizations. The second bullet point kind of offers that the function to meet the architect's form. That's kind of the mantra of the engineer, is to bring the architect's vision to life and to be part of the development of that vision. That's really important to us, and that's where the most effective projects happen, is when that true collaboration happens. Typical roles, a lot of times people will start off being the drafter, doing markups, and And then that moves into more and more design, and then culminating in the, becoming an engineer, which to us means a licensed engineer, a professional engineer, which requires that you have an ABET degree, which Purdue offers many of those. So that's not the path for every MEP engineer, as we're finding a lot of electrical engineering technology, mechanical engineering technology students, as they enter the workforce, they typically, under most scenarios, wouldn't be able to be a licensed engineer, but they still have a big place in that center category, the designer. So mechanical engineers that deal with HVAC, and we split mechanical into HVAC and plumbing in our world. But the HVAC engineers and the mechanical engineers are really focused on thermal loads of the building, the type of system, the cost, the operation, the energy efficiency, the constructability, all those things, and the energy impact. Typical workflow is, you evaluate different options, you perform load calculations, you select equipment, you route that through, you produce a set of construction documents and specifications that a project is bid from. So that's the nuts and bolts of what we do. So in a real basic way, how does air get in and out of the building to ventilate, and how do you keep people comfortable? There's a million different ways to do that. Some really advanced and sophisticated, some very simple, and everything in between. So, that's a little bit more on, how heat and air move in and out of a building. But if that's at all of interest to you, I guess my message to students is that there's a multi-billion-dollar industry there waiting that is in critical need of new talent, new energizing talent. So that's your opportunity going forward. Why is this type of engineering important? Really, to keep people, primarily to keep people safe and secure inside the building. We deal with a lot of existing conditions when we do assessments and we look at old facilities. And as codes have changed over time, there's been a lot of focus on indoor air quality. And that is first and foremost for an HVAC engineer, assessing the safety and the code compliance, and people being thermally comfortable, but also breathing clean air and being in a safe environment. HVAC loads, we calculate what the load is, but we're not designing the piece of equipment. We're applying. So a lot of times the way our HVAC engineering and the AEC industry is framed is we are application engineers is a term that's being used a lot. So we apply thermal science and products that are readily available to a situation to solve a problem, essentially. That's not to say that everything you don't learn in school doesn't apply, right? All the math and the thermo and the fluid mechanics all works hand in hand, and understanding that all that physics and all that math does come in very handy. But we're not designing my point really is we're not designing the pieces of equipment. We're putting together a system that makes sense and solves a problem. Dehumidification is at the heart of all that. If you had to pick the two biggest issues in buildings, it's lack of ventilation and lack of dehumidification. When mold grows, bad things happen, and when people don't have fresh air to breathe, bad things happen, right? And so that's first and foremost for the mechanical engineer. Another kind of technology that goes around HVAC is temperature controls. And like I said, I've spent almost 2 decades in the construction side of temperature controls, and it really helped inform me how systems really work in the real world. But we employ 2 controls engineers on full time one that's more involved in troubleshooting and one that's more involved in design. But there's a whole world out there of just that subset of HVAC, the controls that go inside a building, is an enormous industry. And you see all those big names and Fortune 500 companies involved with that. Electrical engineering is also really important. It basically covers all the lighting, power, and fire alarm is kind of the classic three items that you're dealing with inside a building. So everywhere that equipment needs power or that people need to be able to plug in, the lighting and all the associated controls, and then the fire alarm and safety systems. And then we just have a couple examples of kind of how that fits together. It's really the power distribution, which turns into single line diagrams, and also with all of this, the engineer's creed is always look out for people's safety, life and safety first. Some example plans, just to quickly show you kind of what some of our product looks like. So over on the left is kind of a power plan, and then in the center is a lighting plan. They're just snips of drawings. And then over to the side is kind of a control schematic that shows, for example, how lights get controlled on and off with occupancy sensors, with daylight harvesting, all that kind of thing. Plumbing engineering, which also technically is mechanical engineering, but a lot of people kind of separate that into two disciplines because it is two separate things, two separate groups of items you're worried about in a building. So a plumbing engineer is worried about all the water, the gas, the sanitary, storm, and then anything in a lab building that would be, or a healthcare building would be compressed air, medical gas, and any equipment that would be need utilities. So plumbing engineering, the kind of the mantra is everything within 5 feet of the exterior wall in a building is a plumbing engineer's issue, and everything 5 feet out is really the civil engineer's realm. So you select fixtures, you ensure that all the storm piping and waste gets out of the building. It seems like it is quite often in older buildings when we look at the plumbing systems are they're set it and forget it until it doesn't work, right? And I would say that's kind of a message for all the MEP systems in a building. Nobody usually pays a lot of attention to systems like this unless they don't work. If the lights don't turn on, or if they're hot or cold, or if the restrooms don't function properly, or if there's flooding around the building, that's when an engineer would be most important to engage. Example plumbing plans, we have we have a plan view, and then like in the previous slide, we use Autodesk Revit, and everything's designed in 3D. So that is another thing that really I was sharing with Josh before we started, that one of our electrical engineers actually started off as a computer graphics technology degree from Purdue, and then went back to get his electrical engineering degree. So that was an important kind of foray into our world, is the computer graphics technology. I know it's called something different now, and I've been educated on that. With that, I'll turn it over to Bill and let him talk about the energy aspects of what we do.
All right, thanks, Eric. Before I jump into the full discussion, I'll just give a note about when I was in college. I was an undergraduate chemistry major, but I wasn't sure that's really what I wanted to do, and I took a environmental economics course, and that really stuck with me, especially as it pertained to resource scarcity. So this is 40 years ago, but a long time ago. But in talking about gas, coal, oil, fossil fuels, and everything like that. And even back then, the message from the textbook was that energy efficiency was actually more economical than continuing to dig more coal and drill for more oil. So that resonated with me back when I was 21 years old, and kind of set the course for my career. So it was really, and so I encourage everyone to continue to take interesting courses and really hone what their interests are. So as we turn to energy, can't stress the importance enough of the energy consumption that occurs in buildings as part of the total U.S. energy portfolio here. You can see from that graphic that buildings consume 40% of that total U.S. energy, and then within that, HVAC is a significant portion, almost half of that. So reducing energy consumption within HVAC systems is very important. So since that's so important, the energy standard, the ASHRAE energy standard 90.1 really guides the energy efficiency requirements in buildings. And that graphic on the right shows you that as the ASHRAE standard has improved and changed over the course of time, how energy consumption has dropped as a result of that. So right now in Indiana, we have perhaps the oldest version, the oldest in-place version of Energy Code of the 2007. But if you go out to the coasts, California and New York and other very high-cost energy areas, they are at, I think, 2024 maybe. Yeah. So we are way behind in Indiana in terms of what is required by code, and if our legislature would update that code, then there'd be significantly more savings in buildings, especially new buildings being built. In terms of some of the things we do, we work hand in hand. The Energy Services Group works hand in hand with the MEPT department. We all collaborate together. We all sit together. And so we are, as designs are occurring for equipment, we are, looking at the efficiencies of those pieces of equipment and making sure they might be, qualifying for incentives from the electric utilities within the state, or when it comes to boilers, the gas utilities. So we want to make sure that they're meeting certain efficiency levels that they would, so the customers can get some money back on those energy efficient investments that they're making. Sometimes when you're trying to show a customer or that is not aware of how they're using their energy, we will do this energy analysis basics. And what we'll do is we will gather their energy bills and we'll calculate their energy use intensity. That's a kBTU per square foot per year value. And so the higher the value of that EUI, the greater the energy intensity and the more energy savings opportunity there is in that facility. So a lot of the work we do with schools is with schools. And so a typical EUI value might be somewhere between 45 to 50, an average value like across the country. So if we do that analysis and we come up with a school that has a 60, 70, 80, 90, we know that there's energy saving opportunities that are available at those facilities. And those profiles that we generate, you can see one on the upper right, will also help us look at how their consumption is by month, as well as their kW demand. And if they have some really crazy demand spikes, then how that's driving their energy bills to be higher. So a lot of insight can be learned from some, just getting 2 years of gas and electric bills and then getting the square footage of the facility to really help determine what the next step would be with the customer. Another higher level analysis that we do is actually energy modeling for facilities. And this can be for existing facilities that are going to get a renovation or for new buildings. We will build an energy model, and there's a graphic of one in Energy Plus or other types of energy modeling systems. But that allows us to get a comprehensive view of the facility and what decisions can be made. And sometimes it can be small, sometimes big, but how that will affect the energy consumption in the building and making those decisions in the design phase are really important because those buildings are going to be around for, probably 50 years or more. And so you're building energy efficiency into the building at that point in time using these models, so that over the course of the life of that building, it is a lower cost to operate facility. So those are just a couple things we do in the energy services department. Very simple energy bill analysis to calculate the UI, and then a much more comprehensive energy model example to help customers over the long term. With that, I'll pass it back to Eric.
Sure. So I'll repeat what I said before, that the industry does there is a labor shortage in the AEC industry. I'll state that. So that shortage creates opportunity, right? There are a lot of good paying jobs and inspiring careers available for folks in the AEC industry, on the contracting side, on the design side, and as well. If you are in the engineering, if you are thinking about doing engineering and creating and becoming a professional engineer, I know that maybe some of you aren't, and that might not apply, but in our industry, I'm just sharing our experience. And I had, when I was at Purdue in West Lafayette, one of my favorite professors really pushed us to take the FE exam before we left campus, because he's the way he put it to us is, you guys have been busting your tail for 4 years, and you can knock this test out, no problem. But don't wait several years, because it'll be a lot more difficult. So that was some wonderful advice. There are lots of opportunities, like I mentioned, on the contracting and construction side, on the equipment and manufacturing engineering of all that equipment that we use that application engineering to apply. There's a ton of MEP consulting firms and AE firms where there's opportunities for people to jump in. There's the whole world of temperature controls. And then, of course, there's the research side of everything that's probably more closely tied to ASHRAE and national labs and things as well. So lots of opportunities. Hopefully that spurs some kind of thoughts and questions for you. Thanks for your time.
That's great. We definitely have mechanical engineers, electrical engineer students join our concentration or our certificate program sometimes. And also, I think it's super important, like our students are studying museum spaces and attractions at theme parks and retail, and just lots of different spaces. And probably what they don't think about very often are some of like these important things that go into, building those. Like we need power, we need comfortable and safe air. There's definitely a lot that goes into it. In fact, one of our students are working with the Indiana Dunes Museum right now. I understand the building that they are looking at to use does not have HVAC currently. So yeah, there's definitely things you have to figure out. Otherwise, people aren't gonna come to your space if they're not gonna be comfortable there on a hot summer day.
That's true. That's so true. I could riff on that a little bit, and I would say that another thing that ASHRAE does a good job of is they have these climate zones that kind of segment out the general weather patterns over a period of year or over an average year, and designing in different weather zones in the United States leads to dramatically different solutions. I'll give you the simple example would be, the San Diego dream weather, where everything's in a reasonable humidity and kind of between 65 and say 78 degrees outside all the time. That leads to solutions like, hey, we can just naturally ventilate this building, right? We could even have kind of a passive system where the thermal buoyancy brings the warm air through out the top of the building, and that brings in fresh air that is good for the people to work and live in. So that's great in some weathers, in some climate zones, but for a place like Indiana where you have the bitter cold winter and the scorching hot summer, that those kinds of systems would work for a very short period of time in spring and fall, and you'd have to invest. So I just wanted to bring that up. Where you are on the planet makes a huge difference on how you design, and even where you are located in North America can have a gigantic effect on how you come up with solutions. Something to think about.
I have some questions to transition into on more to the master planning side of things, but before we kind of wrap this topic, I do wonder like is mechanical electrical engineering, in the courses that a standard student takes for that, is this like a specialization or how do they end up working for a company like you on these kinds of projects? Like, is it a certain concentration they get into, or how do they end up kind of in this industry?
I love that question because it's evolved over time. The answer to that question has evolved over time. When I was at Purdue, uh, I was a mechanical engineering student, and I was really interested in buildings and HVAC and construction, uh, just from what I was interested in. Uh, I my senior year, I created a project with one of my favorite professors that involved kind of a very rudimentary uh, solar evaluation tool to kind of see how shading would hit a building and things like that. The reason I bring that up is traditionally it would be mechanical engineering degree, electrical engineering degree, and then the plumbing engineers would just be a mechanical engineer that kind of over the course of their life and interest went that direction. But Purdue has really changed the game on the mechanical and the plumbing side. So there's a degree within the civil engineering school called architectural engineering, and two of my best mechanical and plumbing engineers are graduates of that program. It's extraordinarily good at preparing students for the AEC industry, and I think it's from what I've heard, it's kind of the closest exact match to training in our industry. That architectural, we go to the civil engineering career fair up at Purdue all the time looking for those architectural engineers. And of course, civil engineering covers all kinds of sub degrees. And so there's maybe 50 to 100 people in that program at any one time at West Lafayette. That's to me is kind of the one of the best paths. But a lot of times, well, many people that work at our company and myself had a very circuitous path in their career, right? So when I graduated in '91, it was it was a really tough time economically. So I worked for a nonprofit energy research company in Atlanta, Georgia, called South Face Energy Institute. And so I just kind of left town and worked for this nonprofit. That led to hopefully this is helpful, to hear the arc of a career, but that led to me coming back to Indianapolis when there was a utility energy savings program that I worked for a consulting firm, and then that led to working for the controls contractor, Siemens, namely. And then after I kind of learned what I could from there, I got my license in '04, and then moved into consulting. And then so I've worked for engineering consultants, and now for the last 15 years I've been at Schmidt, where we're an architect engineer. So a lot of people, I would say there's the opportunity to kind of specialize in that architectural engineering degree. I see that as a valuable path, but that's not the path for everyone. A lot of times, after you graduate, life takes you in all kinds of different directions, and that's okay. It's part of the arc of your career, right? So for me, it was a little different, but yeah.
Now, I don't know if you guys are the right experts to ask these kind of questions, but a lot of our students, we're kind of on the concept design side, so we're coming up with sketches, ideas, stories, themes for, like I said, with like the Dunes Museum and how to best tell the story of steel and the interesting sand dunes that are in the area. How does Schmidt go from a concept to actually building something and creating something? Like, what are some of the stages that go into that?
Oh, great question again. So it, a lot of it, the process depends on kind of who the client is and what the stage of the idea forming that has already happened, right? A lot of times we'll end up doing first evaluating. I guess for institutional owners, I'll take it from that side of things. For institutional owners, it's kind of an evaluation of what do you have now and what do you need, right? So that would be kind of an assessment, a conditional assessment or a use assessment of what's currently there. And from there, one of the tools that we use once something has been identified as a need, you want to have a certain facility that does something. That can involve a design charrettes, and also one of the things that we do in order to capture what the end user is really going to need out of a facility, beyond even kind of parallel with the vision, the big picture vision, is what we call a puzzle piece exercise. And what that means is you take manipulatives, literally little foam cutouts of different spaces and different uses of a building, and you put that on a big board on the site, and you push those pieces around and discover what adjacencies are important, why it's important to build something like that looks like this or that performs like this. So there's a lot of different ways that can come together, but I think there's that manual manipulative, the puzzle piece exercise. There's also kind of the design architecture rendering type exercises as well that we do a lot of. I would say when we get into that, from our seat, a lot of that has to do with if we're trying to work for a client. A lot of times we interview for that work along with other firms, and more, what comes up is you need to have a rendering, you need to have a vision, you need to be maybe even a 3D fly through with some music, and it's a lot of bells and whistles. So and it's so much of an effort now that we actually have a full-time person. That's all they do, is that they work with their computer graphics specialists and video. They can create video and audio content. That becomes really important. We've got one person, and that one person is extraordinarily busy. You have to get in line way ahead of time to to get that person's time. So I would say that's another really big growth area in the industry. The ability to be able to capture that vision, work with an architect, but be technologically savvy enough to understand how to portray and create a video or still images that sell a vision.
So you mentioned design charrette is mechanical engineering, electrical, HVAC. Like, do they have a seat at that table at that stage, or when do you guys get brought in?
Yes, we do. And the as an engineer, my perspective, the projects always work better the earlier we're brought in. Sometimes there is that kind of visioning that happens, and maybe there aren't as many engineers, or maybe there's no engineers in the very, very, very beginning. Like kind of what you were talking about is what's the concept? How do we sell the history of the area, or the natural, or how do we enhance or amplify the natural beauty of an area? Maybe at that early conceptual phase, that's not where the engineers are, but it's right after that. Once you have kind of your feet underneath you, and you know why you're doing something and what you're trying to enhance, then the engineers can come in and kind of guide the practical side of it. Here's some options. Here's the space that we might take up. Here's the portion of the project cost that we would take up, and here's an option for either saving on first cost or saving on operating costs. making the space more usable for people. Maybe there's an opportunity to use a geothermal linked system if the geography is right. Maybe there's a lot of wind on the site, and you want to use alternative energy of some sort. Maybe the client, or it enhances the mission to have alternative energy, solar or wind, involved in the project. That's another place where the engineer could offer a lot, and energy engineers.
As engineers, do you find yourself in many situations where there's some friction with the creatives as far as like they want this, they have this big idea with all these things happening, and you're like, hey, we don't have that much power, or like that's not going to work. I mean, do you see that type of stuff often?
Yeah. That's the classic conundrum. That's the classic, almost like it's set up to be that way. There's going to be some friction,
Yeah.
uh, but there's no progress without that friction, right? Would be my take on it. A lot of times, it goes to the soft skills that you learn over time too, when to lean in and when to back off. I think a lot of times the best engineers can still move forward without having all the answers.
Mm.
I know that, and that kind of grinds the gears of engineers sometimes. I need to know everything in order to solve this problem. But
Yeah.
as you gain more experience, you realize that the most influential you can be is to be open to a bunch of different options and offer your experience. Even if you don't know everything about everything yet, you're there to help guide them towards something that will work long term.
Another thing my students are with this Dunes Museum is that right now it's just an idea, and they're trying to figure out a budget and to apply for a grant and those kinds of things. Um, how do you estimate like what something's going to cost? Because I mean, a lot of these things are in the millions of dollars. Is that a very thorough? I mean, you're counting how many two by fours there are going to be and that kind of thing, or how does that estimation come together?
Yeah, that's another great question. It, early in the concept phase, you're mostly doing square foot estimating, I would say, based on experience and based on system type on the MEP systems and construction type on the architectural side. So you're leaning back on the experience and constructability and materials and systems that will work, and plus or minus 10, 15% where that's going to land. And then it's kind of goes back to my previous comment about like you don't have to know everything about everything to come up with a solution, or at least a concept or a couple of options of concepts of what things could turn into. So early on, it's square foot costs, and then as the lines on paper start appearing, uh, then you can use the tools in Revit to, if you really want to know how many feet of 4-inch pipe is in the building, you can ask the computer how much there is, and you can put it in a spreadsheet and you can total it up. But it's important not to try to do a detailed estimate too early, because you're just spinning your wheels and you're wasting time. So it becomes a balancing act. Once you start designing it, then you can get into more counting the widgets. But early on, it's similar projects of the same size. It's square foot costs that are broke, that we understand, because a lot of times when we bid projects, it's a bunch of different bid packages. There's one for electrical, there's one for mechanical, there's one for the general carpentry, there's one for the roofing, there's one for the pavement outside. And so if you have enough experience with that, and you can use those typical percentages and then of total cost as a check, and you can use the square foot costs to get to an overall reasonable budget.
And are you estimating technology needs as well? Like if the client comes in and says, "Hey, we need three giant LED walls in these different rooms," is that going into the factored in as well?
It sure is, and that's one of the things that, depending on how the construction project is contracted, that can be either uh, kind of FF&E cost, furniture, fixtures, and equipment, or it can be part of the main package. And that a lot of that depends on uh, quite honestly, relationships between the owner and I'll go back to the institutional owner because it's a lot of what we do. Sometimes an institutional owner will have a technology company that they use for audiovisual um, and even for security systems and card access systems. They'll have somebody that they trust, and they want to have a similar system throughout their whole campus. So in that scenario, a lot of times that would be kind of a what we'd call a soft cost or outside the main bid package, uh, specifically on the technology side. I hope that answers your question.
And do you have to use a lot of contractors for all the different pieces once it comes to building? I know you guys do a lot of stuff in-house, but um, I mean, you're kind of organizing who pours the concrete and those types of things as well, or
That is another aspect of understanding the AEC industry that's important to clarify. So a lot of times we'll bid. Our job is to create the design and to inspect and oversee the construction, but we don't have the sole responsibility in the construction phase. Quite often, there's a construction manager um, that's sometimes controlling all the budget, depending on the contractual arrangements. So we're not constructors. We're designers and construction. We have a construction administration department, so there are people that go to all the construction meetings, uh, deal with the questions that come up during construction, deal with the paperwork of submittals, which is another process where they provide what they're going to they provide documentation on what they're going to install that has to match what our drawings and our specifications call for. So there's a whole group of folks at Schmidt that's their job to be construction administrators. But typically, there's either a general contractor or a construction manager that's actually responsible for coordinating all the pieces coming together and the construction schedule itself.
another question too, when you're trying to estimate what a project's going to cost and get funders to, invest in that and pay for it and that kind of thing. Are you also providing operational costs? Like this is going to cost however many kilowatt hours of power, that type of stuff so where they can know like year to year how much utilities are going to cost and that type of thing.
Yeah, yes, and I would say we get asked that more by more sophisticated owners and less by less sophisticated owners.
Yeah.
But smart ones will ask that question, or the institutional owners were definitely asked that question.
Hmm.
I'll give you an example. We're doing a K-12 uh, STEM center in Indianapolis here, and it's a campus that has a lot of older facilities, and they really wanted to make they really want to make a splash with the energy performance, and they know they've been interested in well, they've been in essentially an all electric campus, no gas on the site, and so and they've got some arrangements with the local utility about how, and that helps when they use electricity for the heating and cooling. They can be on a special rate that allows it to be more economically beneficial to be an all
Mhm.
electric. So they're real interested in geothermal, and that project is just starting to kick off. But one of the questions is, you know, how much more would it be to have geo? Because we think it would be a really great statement, but also what are the economics? What's the incremental cost, extra cost, and what's the economic benefit to us down the line? We do get asked that question a lot, and it's an important question to answer to be able to answer properly.
That's great. That's great. I think my last question here, then I'll let you guys go. We really appreciate you coming again. Um, we've been to a few places around Indianapolis, most recently the IMS Museum.
Oh,
Um,
great.
is there anything you'd like to talk about like that? What went into that is interesting, or another kind of indie site that might be down the road from us, just like how that project came together and your angle on it.
Yeah, that's a fascinating project and one that I was involved with in the early times. So as you're well aware,
Oh,
since you
sorry, if
guys
I
are,
could interrupt real quick. IMS is Indy Motor Speedway. We have students from all over, so they may not know what that is. Sorry, go
yeah,
ahead.
yeah. So the Motor Speedway Museum in Speedway, Indiana, is this iconic building. It's been there. It's built in the '70s, and they've been trying to get funding to renovate this building and get it out of the '70s for a while. In fact, we interviewed for this project close to a decade ago. And at that point, there wasn't enough internal motion to get the funding. But I think once Roger Penske uh, took control of the speedway, some things changed and some priorities changed. So yeah, when we started that project, one of the things that they were really um, adamant about was the building can't look and feel different from the outside. We don't want to have somebody walk up to this building later and go, this is so different, especially from the outside. When you're walking around those grounds, people have a history with
Mhm.
everything, right?
Mhm.
And so one example of that is they had these chillers, these ancient chillers, one of which was still barely running from the '70s, and they had these condensing units out on grade behind the building. And they said, you can put equipment back out there in that same location, but it better not make any more noise than it does now. And yeah, we even talked about geothermal, and they're like, we're not digging up the ground at the motor speedway. That's not happening.
Yeah.
We don't want anything to look different at the end. And so, and it was another building like the K-12 example I gave before, where it's all electric. And so they were heating this building with electric boilers, which if you're aware of what that economics of that are, it's not great.
Mhm.
It can be really expensive to heat a building just with an electric resistance. So our design included heat recovery chillers that produce heating and cooling, and then use that same spot behind the building where the old condensing units were. There we have some dry coolers out there, and they don't use any more space or create any more noise than the units did before. That's just fans. There's no compressors out there, so everybody was fine. Like, it's going to feel and look the same. Everybody can calm down. But then we were able to use that better technology uh, to kind of uh, produce the cooling for the building, and also as a byproduct, that waste heat gets used in all but the coldest weather. We can just run the chiller and use the heat off the chiller and the cooling off the chiller to satisfy the building loads. So yeah, that was a interesting challenge. You never know what the owner is going to bring to you as a criteria, right? It can't
Yeah.
we if they don't want anybody doing a flyover or a drone video and have it look any different, right? Because it is the way it's this icon of Indianapolis, right?
Yeah, that's
So,
really interesting. Anything on the inside? I know there's like a incredible LED ceiling and there's some hallways
oh
with
yeah.
projection all the way down and there's some great stuff there.
Oh my goodness, yeah. So yeah, that starting line experience. If you haven't been there and seen that, it's something else. But that space, there's an enormous amount of heat all those screens give off, and so that was a situation where we had to kind of decide: is it better to just exhaust that heat, or is it better to try to just pour a bunch of cooling into that room to offset it? And really, what it turned into was a little bit of both, right? So that arched kind of video wall that's on the ceiling radiates a lot of heat that goes up into the plenum, and that plenum is exhausted, and then there's cool air that goes in the room too, and that kind of eliminates the uh, that's a typical strategy for energy efficiency. Energy efficiency: extract the point source of the heating, right? If you're having to overcome a lot, so yeah, that presented a unique HVAC challenge. So there's really kind of a ventilation and a cooling that's happening in that space. But and when you walk in, it's an amazing experience. kind of overwhelming, really.
Yeah, absolutely. Well, that's really fascinating because I mean that's I don't think we get into the weeds on the HVAC needs of the how to get the heat out, and we're just like, hey, throw an LED wall in, that'd be cool. But yeah, there's a whole backside of things that you guys handle that solve those problems of keeping the atmosphere nice and everything. So it's great to hear that. I'm fascinated by all of it.
Feels good to be appreciated for thinking about stuff like that, because quite
Yeah,
often it happens and kind of behind the scenes, and people take it for granted. But there's a lot of thought that goes into it.
Well, I don't have anything else. I didn't see anything come in from the students on any extra questions. Appreciate your all's time and coming and giving us some insights.
Thank you.
Sure. Thank you very much.
All right, well we'll call it here. Thanks so much, and we'll see you. Have a good Friday afternoon.
Thank you.
Thank you, you too.
All right.